Hello, everybody. Welcome back to the next lesson of our Golden Web Blade um, mod. Last lesson, we finished up creating the blade item and doing what it does. Now we're doing the renders. This is actually pretty hard. Um, so yeah, and here's an image that we're going to be going into more later, but not yet. So immediately you can see that we have something new. We have this thing called client with client setup and Golden Web render in here. These things, just don't worry about them too much. You can learn about them in the GitHub. I mean, you can get them in the GitHub and just put it in over here. And then also we have Golden Web Blade PNG over here, also in GitHub, and you can put it in the assets Xebobot textures item part. Okay, so now let's start with the Golden Web render. And actually, this part you don't have to worry about too much. We're focusing on this part, which is the important part here. So let's start. Okay, well, first let's introduce to you some variables w and h. Web.getWidth, web.getHeight, which I added in Golden Web Entity somewhere over here. It basically just gets it's the width and gets the height of the entity. So yeah, self-explanatory. They're floats, so yeah. Okay. And then over here, cover Y, cover X. So we want to take a PNG file and then map it onto the Golden Web, which if you look into the short, that's what happened. There was an image in the middle of the Golden Web. Yeah, so we're coding that. So final float cover X. What? Yeah, final float cover X, cover Y is, well, how much of the panel area the texture should cover. So 47.35. Because also if you look at the shorts I made about it, you'll see that the image only covered like the middle part of it. Okay, and then here you just take the percent, 25%, 35% of the X and Y and just multiply it to get TW and TH. So TW is the width, amount of width that is being covered by the image, and then TH is, yeah, the amount of width that is being covered. Okay. This is like, but down here, this orange thing is the whole web thing, the whole web. So the lines, the web pattern, and then this part is, the middle is the image CTH. So on the Y coordinate there's TH, and then Z there's TW. And you can see TW and this negative TW divided by 2. The top is TW divided by 2. If you do the math, you'll figure out that this just means that this whole place, the whole X is worth TW, because negative TW divided by 2, and then TW divided by 2, you just get TW in the middle. Okay, so then we create integer and X. which is 24, and then integer ny, which is 18. So nx, ny. Ny is 18, and x is 24. So if you read the comment, you can see like you cut the texture. So this is a PNG, the coordinate PNG, the coordinate system for the PNG file, the image on the very right. And then this is another coordinate system. Okay, so integer nx equals 24 and y equals 18, so cut this into 24 by 18 small pieces, so like kind of like a puzzle, and then cut the small patch on the letter 24. So this thing, because we want to map this onto this, right? And then yeah, you want to map each piece onto one, so you want to map this piece up on like over here, corresponding part over here, and this piece to the corresponding part over here. Then these parts, they're kind of like the painter painting on the piece. We're not going to talk about those too much. Right here, color tint. So final integer r equals 25, red, green, blue equals a integer. And that a is the transparency. This is the color. So I think this color is this I think is a trout. This is a light blue, and then a is the integer times this, which if you do the math, 0.5 times 255 is half of 255 times integer. So I think it's pretty transparent. Alright, now we're getting to the hard part. So starting with these two for loops. So we have for a loop. Okay, you have draw the center texture patch using index-based UVs. So I'm going to draw the center patch right here. So for integer IY, so this is the kind of the helper coordinate system, which converts this into itself, and itself into this, and vice versa. So if IY, integer IY is 0, and it's smaller than NY, then keep doing this. So keep running this for loop until 0, and until it uses up like everything over here, and we already know that NY is 18, so we run this 18 times, right? And also, by the way, these boxes are not to scale, so just don't worry about how big they are right now. So float y1 and then math.lerp. And what lerp does is basically just helps maps. It just basically gets the coordinate of the range, I think, yeah, the range, and then maps the y onto the. So y1 is math.lerp, y2 is math.lerp, iy plus 1. So this just maps this part onto this part. Float v1. So v1 is this text thing. v1 is iy divided by ny. And then v2 is 1f minus float i1 iy plus 1 divided by ny. Okay, then we have something similar over here for the x. So basically, these two for loops do everything for the y and the x. by mapping everything onto here. And then for you may be wondering what I would see. What is Z go? Z is this is 2D, so Z doesn't do anything. It's only X and Y. No Z. Alright, now VC text dot vertex math dot color. So this is just like putting in everything, drawing the image and stuff. Now this thing, part B, is full size grid wireframe. So part A is small center texture paths, so focusing on this thing. Part B is drawing this whole thing. So draw wireframe rect pose buffers. Yeah, that's just draws rectangular wireframe grid spanning the full panel, and then private void draw wireframe pose there. You just draw the wireframe, and then these two for loops help define the lines on the wireframe. So the shorts, actually, I'm going to get the shorts up so you can see. Okay. So here I made a keyboard Demon Hunter's image because, well, it's kind of like the golden Hominid from the movie. And you can see the lines over here. This is a better view. So you can see that there's directly around. Well, you can see there are lines, right? That's what we want. So these things don't worry about. Private void draw wireframe rect. So so it just makes it so you draw the wireframe integer. So this is the bright gold color, and bright gold, kind of bright gold. Yeah, it's bright gold. You could say it's yellow too. The yellow slash bright gold color on the fly is this red 5255 228B 120, and then A255 transparency. Alright, so these two for loops draw the line. So the first one draws the vertical line. So if we go back to this image, integer ix equals 0, ix smaller than mx, ix is plus, so ix over here. So ix can be any point on the x, so this for loop just takes every single point on ix, and then this for math.loop, we already know that it takes this ix and then puts it on here. So ix over here corresponding to the corresponding place over here for ix, and then line no, you really only need to pay attention to so z is everything the same, x, and so x and y. So y, so drawing vertical lines, so obviously the y is going to be changed. However, those change in the y, so up, down, down, up thing for vertical lines, like this, they're easy to code because they're all the same length. The x is, well, I guess it's kind of easy to code because it's only plus x, but like the concept is a bit more complex. So for loop, x is different every time. So for a for loop, the x is the same, is in the same place, but every time the cycle goes through, the x changes, and